Hi, my name is Ross Silver, and I am a grad student at Clemson University working with our team to identify and classify the 3FHL catalog of sources. The 3FHL is the most recent catalog of sources detected above 10 GeV. It was comprised using the first 7 years of data from the Fermi Large Area Telescope, or the Fermi LAT. It is a great improvement over its predecessor, the 1FHL, with a total of 1,556 sources in the 10 GeV to 2 TeV range. However, 200 of these sources have no counterpart at any wavelength. It is crucial that we complete the catalog by identifying and classifying every source. To do this, first, we need to find a tentative counterpart in X-rays, which will allow for optical follow-ups to obtain the redshift. A complete catalog gives us the maximum potential to study the EBL, or the integrated emission of all stars in the universe. The EBL absorbs photons with energies from 20 to 50 GeV, so having a larger sample of identified sources in this range will enable further study of the EBL. Also, this catalog will serve as a map of the sky for the next generation gamma ray telescope, the Cherenkov Telescope Array. Our group focuses on the source class Blazars. Blazars are a subclass of active galactic nuclei. When the jets emitting from the supermassive black hole point toward the observer, they are known as blazars. They represent the most populous source class in the 3FHL. There are two types of blazars: FSRQs with broad emission lines in their optical spectra, and BLX without these lines. Our group is working to identify these 3FHL sources by observing them in the X-rays with swift XRT. As seen in the figure, the positional uncertainty of XRT is nearly 60 times more precise than Fermi LAT, allowing a much more accurate position determination. After analyzing multi-wavelength data that suggested these sources were likely blazars, we implemented a machine learning algorithm to determine their blazar type. We used two of the most common methods, decision tree and random forest. Our input parameters that have been shown to differentiate BLX and FSRQs are the X-ray and gamma ray photon index, the variability Bayesian blocks from the 3FHL, and infrared colors. Pictured here is gamma ray photon index versus gamma ray flux that clearly shows a distinction between BLX and FSRQs. From our previous works, we have found 74 X-ray counterparts of 3FHL sources. Our machine learning algorithms have classified 46 as BLX and 5 as FSRQs, matching the trend from the catalog as BLX greatly outnumber FSRQs. We also have published several successful optical classification campaigns using various 4-meter telescopes. In total, we have classified 75 sources as BLX and 4 as FSRQs. In addition, we have redshift estimates or lower limits for an additional 31 sources. To summarize, our group at Clemson has been working to identify and classify sources from the high-energy 3FHL catalog. Doing so will help us study the EBL and prepare for the CTA. We used XRT data to localize potential counterparts for over 70 sources. Our machine learning algorithms and classification campaigns have classified 131 sources with 31 redshift estimates. Thank you for listening, and here are our papers. Please reach out to us if you would like to discuss our work.